Now let's talk about parabolas. So a parabola is the set of all points whose distance from a fixed point, called the focus, is equal to the distance from a fixed line, called the directrix. The point halfway between the focus and the directrix is called the vertex of the parabola. Let's take a look at an app to show you what this all means, and then we'll define everything and go from there. Okay, so the line that you're looking at here, that's my directrix, and I can change the angle of that line using this point B. Although the point B is not part of the construction of a parabola, it's just so I can change where this directrix is. Then I also have a point that I can change called the focus. The focus is a very important point, and the focus is a point that will allow us to calculate any point that exists on the parabola, which is labeled P in this case, because we'll find the distance between the focus and this point P, and then the distance between point P and the directrix. We'll keep those constant, so those two distances will always be the same. So, for instance, this point C, which again is also not part of the parabola's construction, it's just so that I can change the location of the point P. So check out the distance between point C, which is on the line, and the point that's on the parabola. It stays the same as the distance from the point P to the focus. And if you sweep around, there's one particular point where these are well, I guess I'm moving my line accidentally, sorry, where these two distances are the same and you're directly in the center between the directrix and the focus, and that point's called the vertex. If I continue on, now you'll start seeing the familiar shape of the parabola. And this is a very generalized equation. So we could, in fact, define parabolas that are opening left and right using this, or at an angle. So if I leave the directrix at an angle, then I can actually create a parabola that's opening at an angle as well. So this is a very generalized definition. But as long as you find point P by keeping the distance from the focus to that point and to the line itself equal, you'll always sweep out a parabola. And that's what that definition is saying. Now, for our purposes, we'll stick with parabolas that are either opening up and down or left and right. We're not going to worry about parabolas that are opening on an angle. So, that keeps things a little bit simpler. But let's start with parabolas that are opening up and down. So, given a parabola opening upward, with a vertex location at H and K, and a focus located at H and K plus P, where P is a constant for the equation, then the equation for the parabola, it would either look like this, which is a bit messy, because we have this constant 1 over 4 times P. This is solved for Y, which is actually how we do most parabolas, but it's a bit more convenient to not have it solve for Y, but actually express it in this form right here. So x minus h quantity squared equals 4 times P times Y minus K. Okay, so let's talk about each of the different pieces. So this is referred to as standard form. And if you start with a general form equation for a parabola and you complete the square on it, you'd end up in this form right here. Alright, so h and k, those are very visible values here, and that defines your vertex. So that locates the vertex of your parabola. And that's an actual point on the parabola, so that's nice that you can get a particular point. And let me use a different color for that. Alright, now the value p, this is actually the distance from the vertex to the directrix, so this dashed line is my directrix, and also the distance to the focus. as long as you're at the vertex, all right? So it doesn't happen at every single point, but at the vertex it does. So this value p is actually really important in describing the graph of a parabola, because if you can readily find the vertex, which often you can use this value p then to quickly identify where the directrix and the focus is. Now, from there, to continue graphing, there's another important line. There's a line that passes through the focus and extends to two different points on the parabola itself. And this distance works out to be 4 times p, so exactly the number multiplying inside our standard form equation. This has a name. It's called the lattice rectum, and it's a line that happens to be, well, it would be parallel to the directrix. All right, so if you can get the vertex and these 2 points, then you can actually draw a fairly decent sketch of any parabola. If you're asked to identify the directrix, often what I do is I just take the y-coordinate of the vertex and just subtract p. If you need the value of the focus, just take the y-coordinate of that vertex and add p to it. So that makes it pretty straightforward to work with. Now, if your parabola is opening downward, all that means is the value 4 times p is less than 0. If 4 times p is greater than 0, it's going to be opening upward. And in fact, you can divide away the 4, and it really just comes down to the value of p. If p is greater than 0, it would open in the upward direction. If p is less than, you would open downward. Now, in terms of parabolas opening to the left and right, so the form of the equation here is going to look like y minus k quantity squared equals 4p times x minus h. So it sort of just turns around the exact same formula from above. The only difference is which term is squared. So if the x is squared, then it opens up and down. But if the y value is squared, then it opens left and right. And the way that I remember that is I just think of the simplest parabola that I know, y equals x squared. I know that opens upward, so that kind of tells me right away. From there, it really just kind of think in terms of positive and negative. So if your p is positive, it's going to open toward the positive direction, which is the right. And if p is negative, it would open toward the left. Everything else still kind of falls into place, except for the fact that if you're going left and right, you're not going to add p to the y-coordinate. You would add p to the x-coordinate to get the location of the focus, and subtract p from the y or the x-coordinate of the vertex to get the directrix. All right, let's take a look at some examples here. So first off, we have a parabola that we want to put into standard form and graph the result. So to get this into standard form, notice there's only one squared term here, so I would only need to complete the square in just the x variable. And I'll separate that from the stuff with y, but really, actually, I think what I'll do is just move everything with y to the other side, because, in standard form, that's how it is anyway. So let's see. To complete the square, I would take this value here, divide it by 2, which would be -2, and square it, so that would be 4. Then I add 4 to both sides, which gives me x minus 2 quantity squared and 8y minus 8. So that I end up with x minus 2 quantity squared, and 8 is a common factor here, which I can pull out, and that leaves me with y minus 1. Now, this is my standard form. So the center, or the vertex of the parabola, is located at h and k. H is associated with the x variable, so that's 2. K is associated with the y variable, which is 1. Note that in this form, you do take the opposite of both of those numbers because of the way the formula is constructed. And then we have this value 4 times p, which is equal to the constant multiplying the y. Solving that tells me that p is equal to 2. And lastly, I just want to know which way this parabola is opening. So it's going to open, because the x variable is squared, it's either going to open up or down, but p is positive, so that's going to open toward the positive direction, which would be upward. Okay, I think I have everything I need to get a pretty decent sketch here. So let's take a look here. My vertex is at 2, 1, so I'll just go 1, 2, and up 1. So there's my vertex of this parabola. The value of p is 2, so that means I would need to go up 2 more, and that would locate the focus of the parabola. Now remember, it's not a point that's on the parabola. The focus is different from that. All right, but going 2 in the opposite direction, so down 2, that's going to locate the directrix for me. Okay, and then 4 times p is 8, so there's a line that's kind of balanced, so you'd go 4 in both directions, so 1, 2, 3, 4. There's another point that's on the parabola, and 1, 2, 3, 4 this way, there's another point. So the distance between these 2 points is 4 times p, which is 8. And with that, I can get a pretty decent sketch of a parabola here. And that's pretty good. If I wanted the locations of each of these, I really could just read them off the chart. So sometimes it asks you to identify these things. So the vertex clearly was at 2, 1. The focus was just 2 points up from that, so 2, 3. And then the directrix is a horizontal line, which has an equation y equals, and it's going through -1. So that identifies all the different parts. Now here's another example, and this time they're giving us some different pieces of the puzzle, and we have to figure out the equation of a parabola from these pieces. Now I strongly urge you to draw pictures with these, because drawing the pictures involved really help put the pieces together very easily. But trying to do everything just through formulas can get a bit overwhelming. So I have a parabola with a vertex at 4, 3 and focus at 8, 3. So let me just plot those. So 1, 2, 3, 4, 1, 2, 3. So there's its vertex. Then 5, 6, 7, 8. And there's its focus. All right, so regardless what this parabola looks like, it's going to, be opening to the right, okay? Because the vertex has to open toward the focus. So that tells me quite a bit. That tells me first the vertex, which is h and k, is at 4, 3. So that's easy. The value of p is the distance between the vertex and the focus. In this case, p would be 4, and of course it's positive because the focus is in the positive direction, and it's opening toward the positive direction. And that's really all I need. I know it's opening to the right, so the y variable would be squared, so it's going to be y minus k quantity squared equals 4p times x minus h. That's the standard form, and I and just put the different pieces in. So y minus k, which is the y coordinate of the vertex, so 3. P is 4, so 4 times p would be 16. And then x minus h, and that's the x coordinate of the vertex, which is 4. And now we have an equation that would produce this particular parabola. Now, to check these on your calculator, it gets a little bit tricky because your formula is in what's known as implicit form. So that means you don't have a single variable solved for on either side of the equation. And most graphing calculators aren't able to graph equations in this form, in implicit form. So we can't just take this equation as is and draw it in. More advanced computing can do that. So like Desmos is a program online that can do it. So there's a lot of online resources that can graph from implicit form. But your best bet is really just to solve it for x or solve it for y, and change into parametric form of some sort, and then you can draw it and verify from there.